Great. So thank you, Erica, and thank you to the judges for recognizing our work this way. I think, as is up here, I am a postdoc in David Sabatini's lab at the Whitehead, but as Erica alluded to, my other job is across the river at Mass General, where I'm a fellow in pulmonary and critical care medicine. And it was in that context, a little over a year ago, that I was asked to see a young woman who unfortunately suffered for many years with breathing problems. And I think even the non-physicians in the audience can appreciate that something very wrong is going on with her lungs. And just to orient you guys, this is what a normal CT scan should look like. This is a heart. This is your right lung, your left lung. And what you can see is that this young woman unfortunately had an enormous amount of destruction of her lung. And this is at an age really with no good explanation for why this should be the case. And we were pretty sure from a lot of testing that we had done that she didn't have some of the more common things that might do this: cystic fibrosis, immune deficiencies, and other kind of rare but things that you've heard of. And unfortunately, she was sick enough that she needed a lung transplant, 2 lung transplant actually. And we took advantage of that opportunity, though, because this was such a mystery, to do a couple of things. The first was to do whole exome sequencing on her, and that just means we got a full DNA sequence of the entire genome. And the second was, at the time of her transplant, I took her lungs from the operating room, and we did a couple of interesting things with them. And the first is what we were able to do using an in vitro system. So this is in a dish. We can take normal human airway cells, and we can ask them to become an airway. And we do that by growing them in a pretty special media and in a special interface where they're exposed to the air, just like in your airway. And when we do that, normal cells look like this. And these things that are moving are cilia. And cilia are pretty critical actors. They're these tiny little filamentous structures, and their job is to keep the mucus moving. And without them, you end up with a lot of problems. And what we saw in the patient is this. And you may not be able to see it, but there is movement here, but it's clearly not normal. And what that made us worry about was that something was wrong with these cilia, although we didn't know what it was. And we struggled for quite a while, the better part of a year, to figure out what exactly might be the problem here. And I'll suffice to say that we were quite surprised to find some months later that, in fact, what seems to be the wrong is that these cilia are too short. They're stumpy. And not surprisingly, if your job as a cilium is to move things around, to move mucus around, and you're too short, that's not going to cut it. And so what you can see here is that this is the top of an airway, of a group of airway cells. These cilia, many of them are being cut in cross-section, are long, so long, in fact, that they're kind of in and out of the plane of the image, whereas these guys are pretty much coming to an end right here. But as you can see, this kind of imaging, which is electron microscopy, doesn't give us sort of the kind of top-down view we'd like to see the entire region at a glance. And it also doesn't tell us why this might be bad for the patient. And so we took advantage of some really amazing imaging facilities at the Koch to generate some of these images. And these are scanning electron microscopy images. And on the left is what a normal airway should look like. These are bundles of cilia. They stick up nice and tall. And you can imagine that these, all moving at 8 or 9 times a second, are pretty effective at clearing out mucus. And in fact, you can see there's not much mucus here. These are identically prepared, again, in a culture dish, but from the patient. And when we do that, what you can see is a couple of things. Number one, these are stumpy cilia. They're too short to be very effective, and you can see the consequences of that quite readily, where there's a ton of mucus here. And so what we believe is sort of analogous to something like cystic fibrosis, where the problem is the mucus. In this case, the problem really is that the cilia don't work right. We've gone on to show, just in the last couple of months, that this in fact represents a new human disease caused by a genetic mutation in a special protein that's important for keeping these cilia the right length. I'd like to thank Dr. Sabatini, David, who's been my mentor through this project, Marty Taylor, who's a co-postdoc in the lab with me, who helped me to make these images as pretty as they are, the Koch Nanotechnology Materials Core, David in particular, who sat with me through a lot of imaging and was very patient with my lack of knowledge about EM, and of course the patients themselves who volunteered their time and tissues for this work. My funding source is here, and I'm happy to chat afterwards about any questions.